Hi student, in last lecture we solved exercise number 1.3 questions up to question 2, sub questions first and second. Now we solve next question number 3. 1 is equal to log x raised to x minus cos x raised to cos x. Cos x raised to cot x. So again here we cannot apply directly logarithm on both sides because there is no rule for this. That is log of m minus n is not equal to log m minus log n. So here don't take logarithm. This is not equal. So here we can't take logarithm. So first step, let's consider u is equal to log x raised to x and v is equal to cos x raised to cot x. Cos x raised to, when we take logarithm on both sides, if there is product or there is division of functions, then we take logarithm. Here if it is addition or it is subtraction, then we can't apply logarithm on the sides. Now here consider this as a u and this as a v. So our y becomes y is equal to u minus v. Then how to find dy by dx? That is dy upon dx is equal to du upon dx minus dv upon dx. Say equation number 1 here. We have to find the value of this dy upon dx. Now for this, first we find du upon dx and dv upon dx. Now take first, let u is equal to log x whole bracket raised to x. Now here we take logarithm on both sides. Taking logarithm on both sides. On both sides. So here we get log u is equal to log of, look at very carefully, log of log x. Here only we apply logarithm on both sides. Log of function as it is. Therefore, log u is equal to, now this log of log x raised to x, it can be become log of log x into log of log x into log of log x. Now there are two functions, first one is x and second is log of log x. Now take differentiate with respect to x. Differentiate with respect to x. Therefore, what is the derivative of log u with respect to x? First derivative of log u is 1 upon u. Then derivative of u is du upon dx is equal to. Now for finding the derivative of this, we have to use product rule here. So first x keep as it is into take the derivative of log x plus, now here we take derivative of log x and in second function keep it as it is, log x as it is, into take the derivative of first function, that is x, is equal to x into, now tell me the derivative of log f of x. Now this is in the form of log f of x and function is what here? Log x. So here derivative of this is 1 upon log x into, multiply the derivative of function. What is function here? Log x. So what is derivative of log x? That is 1 upon x. Plus write this log of log x as it is. Now here x and this 1 upon x will get cancelled. Therefore the remaining part is 1 upon log x plus log of log x. 1 upon u into du upon dx. But we have to find value of du upon dx. So this u, write the value of u. What is u? Log x raised to x in bracket 1 upon log x. Here I am using value of u directly plus log of log x. Say equation number 2. This is our equation number 1. Now the du upon dx is equation 2. Now we have to find dv upon dx. Again, what is v? V is equal to cos x raised to cot x. Cos x raised to cot x. Again take differentiate, take logarithm on both sides. Taking logarithm on both sides. Therefore, here we get log v is equal to cot x into log of cos x. Cot x into, apply the log on cos, that is log of cos x. Now we can differentiate with respect to x. Differentiate with respect to x. Then what is derivative of log v? 1 upon v. dv upon dx. That is derivative of v with respect to x. Again here we use product rule since cot x as it is. Now derivative of log of cos is 1 upon cos. Into multiply the derivative of cos, that is minus sin x. Plus write this log of cos as it is. Into what is derivative of cot x? That is minus cos x square x. It is minus cos x square x. Therefore, this dv upon dx is equal to x into, v into. Now look at here, cot x and the minus sign upon cos. Cot and here sin upon cos, that means it is tan, and cos means, cot means cos upon sin. Since the cot and this tan will get cancelled here, because cot x means cos x upon sin x. Tan and cot are inverses of each other. Since this will get cancelled, so here the remaining value is minus 1 only, plus, because this sign here I am writing minus cos x square x into log of cos x. And from this, if we take minus sign outside, then dv upon dx is equal to minus, right, value of v, cos x raised to cot x in bracket 1 plus cos x square x into log of cos x. Now equation number 3. Now write from 1, 2 and 3. From 1, 2 and 3 we write the answer. Therefore, from equation 1, 2 and 3, right, dy upon dx is equal to, what is du upon dx? From 2 log x raised to x in bracket 1 upon log x plus log of log x. Now here minus cos x raised to cot x, and in bracket write the value as it is 1 plus cos x square x into log of cos x. This is our whole dy upon dx of question number 3. Now see what is next question. Question number 4. Y is equal to x e raised to x plus log x raised to sin x. X e raised to x plus log x into sin x. Again here can't apply logarithm on both sides because there is addition. So again we consider, let us consider that u is equal to x e raised to x and v is equal to log x raised to sin x. Then our function y is equal to here u plus v. Since value of d1 upon dx is equal to du upon dx plus dv upon dx. So this is equation number 1. Now finding the du upon dx and dv upon dx, we have to take the derivative of this u and v. Now u is equal to x e raised to x. So taking logarithm on both sides. Logarithm on both sides. Therefore here we get log u is equal to log of x e raised to x. Therefore, what is derivative of log u? equal to e raised to x into log x by using exponent law. Differentiate with respect to x. Derivative of log u 1 upon u du upon dx. Now again for finding the derivative we use here product rule. E raised to x, derivative of log is 1 upon x plus log x into derivative of e raised to x is e raised to x. Du upon dx is equal to u into log x into e raised to dx. From this we take e raised to x common. What is value of u? X e raised to x. And from this we take e raised to x common. So here 1 upon x plus equation number 2. This is the value of du upon dx. Now find dv upon dx. Again what is v? V is equal to log x raised to sin x. Taking logarithm on both sides. Therefore, log v is equal to sin x into log of log x. We apply log on this function log x. Now differentiate with respect to x. Since derivative of log v 1 upon v, derivative of v dv upon dx. Again use product rule here. Sin x into derivative of log x, that is 1 upon log x, into derivative of log is 1 upon x, plus write this log of log as it is, into derivative of sin is cos x. Therefore dv upon dx is equal to v into sin x upon x log x plus log of log x into cos x. Therefore dv upon dx is equal to, use value of v, log x raised to sin x into sin x upon x into log x plus cos x into log of log x. Say equation number 3. Now write from 1, 2 and 3. Therefore from 1, 2 and equation 3, value of dy upon dx is equal to, first write du x e raised to x into e raised to x 1 upon x plus log x plus, right, value of dv log x raised to sin x into, write this bracket below, sin x upon x into log x plus cos x into log of log x dy upon dx. Question number 4. Now see next question, question number 5. E raised to tan x y is equal to e raised to tan x plus log x raised to tan x. Log x raised to tan x. Again here we can't apply logarithm directly, so take e raised to tan x and v is equal to log x raised to tan x. Since again y becomes u plus v, therefore dy upon dx is equal to du upon dx plus dv upon dx. Say question 1 and finding this two value. Let u is equal to e raised to tan x. Here we find derivative of this e raised to tan x directly because this is in the form of e raised to f of x. This is in the form of e raised to f of x. So here we can't take logarithm, we take direct derivative. Differentiate with respect to x. Therefore, du upon dx is equal to, what is derivative of e raised to f? Is e raised to f into f dash of x. So here write the derivative of e raised to tan as it is. E raised to tan x into multiply the derivative of tan x. Therefore, du upon dx is equal to e raised to tan x into, what is derivative of tan x is sec square x. Equation number 2. First we get the answer of du upon dx. Now next find dv. Then v is equal to log x raised to tan x. So taking logarithm, you can't take derivative directly, so apply log on both sides. Therefore, log v is equal to log of log x raised to tan x. Log v is equal to tan x into log of log x. Tan x into log of log x. Now take differentiate with respect to x. One upon v dv upon dx. Again use product rule for finding the derivative. Tan x into derivative of log is 1 upon log x, and into derivative of log is 1 upon x plus. Write this log of log as it is, and into derivative of tan is sec square x. Therefore, dv upon dx is equal to v into tan x upon x log x plus sec square x into log of log x. Write the value of this. What is v? Tan x raised to log x raised to tan x into tan x upon x into log x plus sec square x into log of log x. Equation 3. Now again from this 1, 2 and 3 we write 1, 2 and 3 d1 upon dx is equal to e raised to tan x into sec square x plus, this is dv du, write dv log x raised to tan x, and in bracket tan x upon x log x plus sec square x into log of log x. This is dy upon dx. These type of questions are very easy, but you have to take the calculations very carefully and write the formulas. First of all, you must know the formulas of derivative, that is inverse trigonometric functions. Now, next question is there. Question number 6. Y is equal to sin x raised to tan x plus cos x raised to cot x. In question number 3, we already find the derivative of cos x raised to cot x. Let u is equal to, and v is equal to cos x raised to cot x. Therefore, y is equal to u minus v minus or plus, there is, here it is plus sign, so here plus. Plus dt upon dx. Now finding the derivatives. Sin x raised to tan x. Taking log on both sides. Therefore log u is equal to tan x into log of sin x. Differentiate with respect to x. Derivative of log u 1 upon u du upon dx is equal to tan x as it is into derivative of log of sin 1 upon sin into derivative of sin is cos plus log of cos as it is into derivative of tan is sec square x. Therefore du upon dx is equal to u into, now look at here, tan means what? Sin upon cos. Tan means sin upon cos. So here, and cos x upon sin, that is cot. So again tan and cot will get cancelled. The remaining value is only 1 here. 1 plus log of sin x into sec square x. Use value of u is equal to, what is u? Sin x raised to tan x. In bracket 1 plus sec square x into log of sin x. Equation second. Value of du upon dx. Now see next week. What is v here? Cos x raised to cot x. We already find the derivative of this cos x raised to cot x. In question, example number 3. Taking logarithm on both sides. Therefore, log v is equal to cot x into log of cos x. Differentiate with respect to x. Since derivative of p 1 upon p dp upon dx is equal to, use product tool here. Cot into derivative of log of cos x into derivative of cos minus sin plus, right, log of cos as it is into derivative of cot is minus cos x square x. Therefore dv upon dx is equal to v into, again look at here, sin upon cos and here cot, that means again tan and cot will be cancelled. The value is minus 1 minus cos x square x into log of cos x. Now take the minus sign outside, is equal to minus, what is v? Cos x raised to cot x, and in bracket 1 plus cos x square x into log of cos x. See equation number 3rd. And write from 1, 2 and 3. Therefore, from 1, 2 and 3, then dy upon dx is equal to, what is 2? Sin x raised to tan x in bracket 1 plus x square x into log of sin x minus cos x raised to cot x into 1 plus cos x square x into log of cos x. Final dy upon dx of example number 6. Now see last question in question number 2, which is based on logarithmic differentiation, which is very important question also. In exam it is asked for 3 marks, 4 marks. See what is question? Y is equal to 10 raised to x raised to x plus x raised to x raised to 10 plus x raised to 10 raised to x. X raised to 10, then x raised to 10 raised to x. Again consider here that u is equal to 10 raised to x, v is equal to 10 and w is equal to x raised to 10 raised to x. Then our y becomes y is equal to u plus v plus w. Then dy upon dx is equal to, right, du upon dx, dv upon dx and dw upon dx. See, this is, now here we have 3 functions and in our earlier examples there are only 2 functions, here 3. So first take u is equal to 10 raised to x raised to x. Now here we can't take logarithm because this is of the form a raised to f of x. This is of the form because the 10 is constant here, that is in the term of a raised to f of x. But finding the derivative of x raised to x, we have to take logarithm on both sides. So first we don't take log on both sides. First we differentiate. Differentiate with respect to x. Then du upon dx is equal to, what is the derivative of this? A raised to f of as it is into what? Log a into f dash. So I am writing here 10 raised to x into log a means here log 10 into, take the derivative of function. What is function here? X raised to x. Now here we have to find the derivative of this x raised to x. So here I am taking input x raised to x is equal to, suppose like z is equal to x raised to x. Again we can't find the derivative of this x raised to x. So here we have to take logarithm on both sides. Taking log on both sides, and in last lecture in many examples we find the derivative of this x raised to x already. Here we also find the derivative on both sides. Therefore log z is equal to x into log x, and if we take differentiation, the derivative of this log z 1 upon z into dz upon dx is equal to x into derivative of log 1 upon x plus log x. That means value of this dz upon dx is equal to this z right here. So what is value of z? X raised to x. In bracket x will get cancel 1 plus log x. So from the derivative of dz upon dx, what is the derivative of this x raised to x? That is x raised to x into 1 plus log x. We put the value here. Therefore, du upon dx is equal to, write this 10 raised to x into log 10 into derivative of x raised to x is x raised to x into 1 plus log x. This is du upon dx, equation number 2. Now next v. V is equal to what? X raised to 10. Taking log on both sides. If we can't take derivative, then take logarithm. Log v is equal to x raised to 10 into log x. Take differentiation. 1 upon v, dv upon dx. Use product rule. X raised to 10, derivative of log is 1 upon x plus log x into derivative of x raised to 10 power function, that is 10 x raised to 9. Therefore, dv upon dx is equal to v into x raised to 10 upon x. That means here we write x raised to 9. plus x raised to 9 into log x, and from this we also take x raised to 9 common. Therefore dv upon dx, write the value of phi. What is v? X raised to 10 in bracket into log x. Equation number 3. Next one, w is equal to x raised to 10 raised to x. Again can't take derivative, so take logarithm. Taking logarithm, therefore log w is equal to 10 raised to x into log x. Differentiate 1 upon w, dw by dx is equal to 10 raised to x. Derivative of log x is 1 upon x plus log x as it is. Derivative of 10 raised to x, which is a raised to x. Then derivative is 10 raised to x into log 10. Therefore dw upon dx is equal to w into 10 raised to x upon x plus 10 raised to x into log x into log 10. So use value of w, dw upon dx, right? Value of w, x raised to 10 raised to x, and from these also we take 10 raised to x common. Therefore there is 1 upon x plus log x into log 10. Equation number 4 here. So write from 1 to 1, equation number 2, this is 3 and 4. From equation 1, 2, 3 and 4. Very important example in exam. We have part or a whole part asking for 3 or 4 marks. What is first equation here? So second, 10 raised to x into log 10 into x raised to x into 1 plus log x plus, this is du upon dx. Now next dv. From this also we take x raised to 9 common.